Hello, today we are going to do some more MCQs from Mathematical Induction chapter. So let us go for the first question after what we did in the previous class. The first question I'm going to write is the greatest positive integer which divides n plus 1 into n plus 2 into n plus 3 and so on up to n plus r for all n belonging to set of natural numbers is, it can be r, it can be r factorial, it can be n plus r, or it can be r plus 1 factorial. So already when we were doing shortcut methods, I told you if we have product of r consecutive, let me erase this. I want to write consecutive. So if you have product of r consecutive integers, then it is divisible by r factorial. So I have n plus 1, n plus 2, n plus 3, like that, n plus r. So these are product of r consecutive integers. That means obviously it will be divisible by r factorial. So we can go for option B. Let's go to question number 2. The question number 2 is the greatest positive integer which divides n into n plus 1 into n plus 2 into n plus 3 for all n belonging to n is, the options are 2, 6, 24, 120. Now again you can see we have consecutive integers. We have 4 consecutive integers. What are they? First is n, then next n plus 1, n plus 2, n plus 3. That means it will be divisible by 4 factorial, that is 24. So option C will be correct. Question number 3. We have a statement P of n, that is n square plus n is odd. And then it is seen that if P of n is true, implies P of n plus 1 is also true. Then you have to say P of n is true for all. Options are n greater than 1 or n greater than 2 or none of these. So in order to see that, we have to put n equal to 1, so that we will get p of 1 as 1 square plus 1. It is odd number. We will put n equal to 2. P of 2 is 2 square plus 2, 6. But this is not odd number. We can't take in Pn. When you put n equal to 3, P of 3 is 3 square plus 3. 9 plus 3, 12. This is also not odd number. Actually, in the beginning also we got 2. This is also not odd number. 2 is also not an odd number. So, everywhere we are getting that it is not an odd number. That means I can say none of these will be true. Coming to question number 4. The statement P of n is 2 plus 4 plus 6 up to 2n for all n belongs to n. It is given that P of k is k into k plus 1 plus 2. Implies that P of k plus 1 is k plus 1 into k plus 2 plus 2 for all n. So we have to conclude that P of n equal to n into n plus 1 plus 2 is true for all. Option A is n belonging to set of natural numbers, n greater than 1, n greater than 2, and last one is none. So first, I will take n equal to 1. That means I will take P of 1. That means I will take 2. So this is equal to 2 into, I'll put 1 into this. Right side also, I will put and see whether I will get 2 or not. One by one I will put. So I'll put 1 into 1 plus 1 plus 2. So I am getting 4 here. I am not getting 2. So for 1, it is not true. I'll put n equal to 2. So P of 2 will be 2 plus 4. Whereas in the formula, when I put k as 2, actually instead of n equal to 2, n equal to 1, we can take k equal to 1, k equal to 2, because the statement is P of k. Here, of course, it is P of n. So that way also you can take. So P of 2 will be 2 plus 4, whereas in P of k, if k is 2, 2 into 2 plus 1 plus 2. Here we are getting 6, but here we are getting 8. These two are not equal. So it is not true. Next we will put k equal to 3. So P of 3 will be 2 plus 4 plus 6. That is 12. Whereas on the other hand, I have k as 3. 3 into 3 plus 1, 4 plus 2. You are getting 12 plus 2, 14. So these two answers are not matching. That means you have to take none. Let us go to question number 5. We will take the inequality. The inequality is n factorial is greater than 2 power n minus 1. This is true when for all n or n greater than 1 or n greater than 2 or none. Which one is correct? So to prove that, again we will start with n equal to 1 and we will find p of 1. 1 is greater than 1. This is false. Next we will do n equal to 2. P of 2 means what? 2 factorial is greater than 2 power 1. So this is also false because 2 can't be greater than 2. 2 has to be equal to 2. Next n equal to 3. So P of 3 will be 3 factorial greater than 2 square. 6 is greater than 4. So from here you are getting true. That means after n, for n greater than 2, the statement will be true. Let's go to question number 6. The smallest positive integer n for which n factorial is less than n plus 1 by 2 whole power n. Option A is 1, B is 2, C is 3, D is 4. I will write again. Question number 6. The smallest positive integer n such that n factorial is less than n plus 1 by 2 whole power n. Option A is 1, B is 2, C is 3, and D is 4. So in order to prove that, first we will begin with n equal to 1. 1 factorial is less than 1 power n. This is false. So n equal to 2. 2 factorial less than 2 plus 1, 3 by 2 whole square. So 2 is less than 9 by 4. Yes, this is true. Put n equal to 3. 3 factorial is less than 3 plus 1, 4 by 2 whole square. 6 is less than, because n we are taking 3, this must be whole cube. The power must be whole cube. And 2 cube we are getting 8. This is also true. So from 2 onwards, it started becoming true. So you have to go for option B. Let's go to question number 7. In question number 7, x into x power n minus 1 minus n into a power n minus 1 plus a power n into n minus 1 is divisible by x minus a whole square for option A, n greater than 1, Option B, n greater than 2. Option C, for all n which is a natural number. And D is none of these. So here also, in order to prove this, we will start with n equal to 1. So we have x into x power 0 minus 1 into a power 0 plus a power 1 into 1 minus 1. That means we have x into 1 minus 1 plus 0. That is 0. Of course, 0 is divisible by 0 is divisible by any number. It is divisible by x minus a whole square also. Now we will put n equal to 2. X into x power 1 minus 2 into a power 1 plus a power 2 a square, because everywhere we are putting x as 2, a square into 1. That means we have x square minus 2ax plus a square. Clearly it is x minus a whole square. So I can say this is divisible by x minus a whole square. So for n greater than 1, this statement is proved. It is true. Next is question number 8. If n is a positive integer, so n is any positive integer, then 2 into 7 power n plus 3 into 5 power n minus 5 is divisible by which number? It can be 24, it can be 64, it can be 17, it can be 676. So I will take P of n statement as 2 into 7 power n plus 3 into 5 power n minus 5. First I will put n equal to 1. So P of 1 will be 2 into 7 plus 3 into 5 minus 5. 14 plus 15 minus 5. So it is 24. That means obviously it will be divisible by 24. Coming to question number 9. If n is a positive integer, then 4 power n minus 3n minus 1 is divisible by which number? It can be 3, it can be 9, it can be 8, it can be 27. So to find out this, we will take the statement P of n as 4 power n minus 3n minus 1. For n equal to 1, the statement becomes 4 minus 3 minus 1. 0 is divisible by all numbers. We need not check. Now I will put n equal to 2. P of 2 is 4 square minus 6 minus 1. 16 minus 6 is 10 minus 1, 9. So of course 9 is divisible by 3, 9 is divisible by 9. But what we will take highest common factor. For 3 and 9, we will find HCF. 3 ones, 3 threes. So HCF is 3. 3 into 3, that is 9. That means I can say it is divisible by 9. I can select by taking the HCF. So we will go to question number 10. If n is a positive integer, then 2 into 4 power 2n plus 1 plus 3 power 3n plus 1 is divisible by which number? It can be 2, it can be 9, it can be 11, it can be 27. That is option D. Okay, to prove this, I will take P of n as 2 into 4 power 2n plus 1 plus 3 power 3n plus 1. I'll put n equal to 1. Then I will have 2 into 4 cube plus, because I'm putting n as 1, plus 3 power 4. So I will have 2 into 64 is 128. And 3 power 4 is 81. So I'm getting 209. Clearly 209 is not divisible by 2, not divisible by 9, but it is divisible by 11. So we can take 11 as the option, correct option. Next we will go to question number 11. In question number 11, it is asked 49 power n plus 16n minus 1 is divisible by which number? It can be A, it can be 4, it can be 19, it can be 29. So in order to prove this, I will take the statement Pn as 49 power n plus 16n minus 1. So if I put n equal to 1, P of 1 will be 49 plus 16 minus 1. 65 minus 1 is 64. So 64 is not divisible by 3. It's not divisible by 19 and 29. So it has to be divisible by 4. Next is question number 12. 10 power n plus 3 into 4 power n plus 2 plus 5 is divisible by which number? In options given are 3, 4, 9 and 15. As I have taken in all the questions, I will take the Pn statement 10 power n plus 3 into 4 power n plus 2 plus 5. So that when n equal to 1, P of 1 will be 10 plus 3 into, because I'm putting 1 as 3, 4 power 3 plus 5. So this is 10 plus 4 cube is 64. 64 you are multiplying by 3 plus 5. So that becomes 10 plus 3 into 64 is 192 plus 5. So total it is becoming 207. 207 is divisible by 3 but not by 4. 207 is divisible by 9 but not by 15. So it has to be either 3 or 9. How will you decide? We will go to n equal to 2. P of 2 is 10 square plus 3 into 4 power 4 plus 5. That is, I can write P of 2 as 10 square, 100. 4 power 4, 256. So 3 into 256 plus 3 into 256. And the last term is plus 5. So when I add all these, I will get 873. Again, this is divisible by 3. This is divisible by 9 also. So which is the highest factor? 9. This is divisible by, from the options, 3 and 9. But how will you say one answer? You have to go for HCF of 3 and 9. 3 once, 9 once, because you can't go further. That's it. So in order to find HCF of 3 and 9, what we have to do is 3 ones, 3 threes. That means 9. So it is divisible by 9. We have to go for C, cancelling A. Next, we can go to question number 13. Question number 13 is 3 power 3n. 3 power 3n minus 26n minus 1 is divisible by 239 or 547 or 627 or 676. Which one? So in order to prove this, we will again take the statement P of n, that is 3 power 3n minus 26n minus 1. If I put n equal to 1, I will have P of 1. And that will be 3 cube minus 26 minus 1, which is 0. Of course, 0 will be divisible by any number. So this will not work. I will put n equal to 2 and I will check. So I will have 3 power 6 minus 26 into 2 minus 1. 3 power 6 is 729. 26 into 2 is 52 minus 1. So this will become 676. That means it is divisible by 676. So let's go to question number 14. In question number 14, we have 2 power 3n minus 7n minus 1 is divisible by which number? That we have to find. So in the options, we are given it can be 36, it can be 64, it can be 49, it can be 25. So I will take P of n statement as 2 power 3n minus 7n minus 1. I'll put n equal to 1. Then P of 1 will be 2 cube minus 7 minus 1, which will be 0. Of course, 0 is divisible by any number. So we will put n equal to 2 and we will find P of 2. That is 2 power 6 minus 14 minus 1. 2 power 6 is 64 minus 14 minus 1 will give us 49. That means it has to be divisible by 49. Coming to question number 15. Question number 15 is if n belongs to set of natural numbers, then three into 5 power 2n plus 1 plus 2 power 3n plus 1 is divisible by which number? It can be option 25, or I will give you different options. Let me erase this one. Okay, option number A, I will take 24. B, I will take 64. C as 31. And D as 676. Now, in order to prove this, I will take P of n as 3 into 5 power 2n plus 1 plus 2 power 3n plus 1. If I put n equal to 1, P of 1 will be 3 into 5 cube plus 2 into, we have 2 power, not 2 into, just 2 power 4. So first of all, I will take 3 into 5 cube, which is 125. 5 5 is 25. 25 into 5, 125. Plus 2 power 4 is 16. 3 5 is 15. 3 2 6 plus 1. And then 3. So what is happening here is there is a mistake in the question, I think. Let me write this question again. Question number 15. 3 into 5 power 2n plus 2, not plus 1. Plus 2 power 3n plus 1 is divisible by which number? That's the question. So the options are 24, 64, 31, 676. To prove this, I will take P of n as 3 into 5 power 2n plus 2 plus 2 power 3n plus 1. If I take n equal to 1, then I will have P of 1 equal to 3 into 5 power 4 plus 2 power 4. That is 3 into 625 plus 16. And that will be 1875 plus 16. That is equal to 1891. Obviously, it can't be divisible by 24, 64, and 677. So it has to be divisible by 31 because all these are even numbers. At the end, you can't have odd number 1. Like that way, you have to decide. Next, we will go to question number 16. 7 power 2n. It is not plus. 7 power 2n minus 48n minus 1 is divisible by. Options are 25, 26, 1234, 2304. I will take the statement P of n as 7 power 2n minus 48n minus 1. For n equal to 1, P of 1 will be 7 square minus 48 minus 1, which is 0. Of course, 0 is divisible by all. Now, if I put n equal to 2, P of 2 will be 7 power 4 minus 48 into 2 minus 1. Now, 7 power 4 is 2401. 48 into 2 is 96 minus 1. So the final answer is 2304. So this will be divisible by 2300. Next, we will go to question number 17. Question number 17 is 7 power 2n plus 3 power n minus 1 into 2 power 3n minus 3 is divisible by. Which number? As per the options, it can be 24, it can be 25, it can be 9, it can be 13. So to prove this, we will take P of n statement as 7 power 2n plus 3 power n minus 1, 2 power 3n minus 3. Put n equal to 1. P of 1 is 7 square plus 3 power 0 into 2 power 0. So that is 49 plus 1, 50. Clearly, 25 is the only number which can divide 50. Next, question number 18. Question number 18 says, x power 2n minus 1 plus y power 2n minus 1 is divisible by which number? A option says x plus y. B says x plus y whole square. C says x cube plus y cube. And D says none of these. So to prove this, we will take P of n statement as x power 2n minus 1 plus y power 2n minus 1. We need not put this brackets. So if I put n equal to 1, P of 1 is x power 1 plus, because when I put n as 1, I'm getting 1, y power 1. So this is divisible by x plus 5 clearly. Let's go to question number 19. It says n into n plus 1 into 2n plus 1 is divisible by. The options are 6, 8, 15 and none. To prove that, we will take P of n as n into n plus 1 into 2n plus 1. I will take n equal to 1. P of 1 will be 1 into 2 into 3. That is 6. So clearly, I can say it is divisible by 6 directly. I need not go for the other terms also. Next, we can go to question number 20. In question number 20, we will take S of k as 1 plus 3 plus 5 plus go on up to 2k minus 1, which is given as 3 plus k square. Now, which of the following is true? That's the question. So in option A, it is said S1 is correct. Option 2, it says if Sk implies S of k plus 1. Or question number C says S of 2 is false. Or I will give you this option. I will change this option. I will give you S of 2 is correct. Then I will say none. Fourth option D. A, B, C, D. Okay, so if I write S of K is 1 plus 3 plus 5 up to 2K minus 1, which is equal to 3 plus K square. If I put n equal to 1, S of 1 will be starting with 1 and ending with 1. And on the other side, you have 3 plus 1 square. So 1 cannot be equal to 4. Or S of 1 is false. I can say that. That means the first option, S of 1, is correct. That is wrong. Next, second option I will see. I will show this on the new page because there is no place. If S of K is true, that means I have to write S of K as 1 plus 3 plus 5 up to 2K minus 1, and that is equal to 3 plus K square. If I write like this, and I will say it is true, then I have to show S of K plus 1 is true or not. S of K plus 1 means what? 1 plus 3 plus 5 up to 2n. Two K minus 1 is there. So before writing K plus 1, I will write 2K minus 1. Then I will write 2 into K plus 1 minus 1. Until here, because this is true, I can write 3 plus K square. And after that, I will write 2K plus 1. So this I can write as 6K plus 3 plus 2K cube plus K square. Now, in order to prove this, what will I do? Because until here I have 3 plus K square. And after that, the next term is 2 into K plus 1. That is 2K plus 1. I am multiplying. So what I can write is I have to get this answer. I have to get 3 plus K plus 1 whole square. How to get 3 plus 1? 3 plus K plus 1 whole square. I am taking, let S of K be true. S of K is true means I will write S of K as 1 plus 3 plus 5 plus 2k minus 1, 2k minus 1, and that is already given as 3 plus k square. So, if I take s of k plus 1, I will have 1 plus 3 plus 5 up to 2k minus 1. Then after that, the next term will be 2 into, I will write k plus 1 minus 1. All these from the top, I can write it as 3 plus k square. And then here I have 2k plus 1. So I can write this as 3 plus k plus 1 whole square directly. Then I can say that s of k plus 1 is also true. So that means I can go to option B. If s of k is true, s of k plus 1 is also true. Next, we will go to question number 21. As per question number 21, P of n is a statement 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial, so on, n into n factorial, which is given as n plus 1 factorial minus 1. So I have to show that this is true for all n greater than 1 or not true for any n or true for all n belongs to natural numbers or none. So in order to prove this, I will take n equal to 1. The Pn statement becomes starting with 1 into 1 factorial and ending with 1 factorial. 1 into 1 factorial. But on the other side, I have 1 plus 1 factorial minus 1. So this side it is 1, this side also 1. So this is true. For n equal to 1, it is true. Similarly, we can take n equal to 2. This is P of 1. Now I have P of 2. Start with 1 into 1 factorial, then end with 2 into 2 factorial. But then answer should be, when you put n as 2 plus 1 factorial minus 1. So this is 1, this is 4. That is, we have 5. Here 3 factorial is 6 minus 1, which is also giving us 5. That means I can say it is true for all values of n, picking up in that way. Now we will go to question number 22. In question number 22, it's given 2 plus square root of 3 power n plus 2 minus square root of 3 power n is, the options are an integer for all n. Option B is, it is an integer if n is even. Option C is, it is an integer if n is odd. And option D is irrational number always. To select one of the options, first I will take P of n statement as 2 plus root 3 whole power n plus 2 minus root 3 whole power n. I'll put n equal to 1. P of 1 will be 2 plus root 3 plus 2 minus root 3, which is an integer. I'll put n equal to 2. So P of 2 will be 2 plus root 3 whole square plus 2 minus root 3 whole square. So as per this, I can write 2 into 4 plus 3, that is 14. This is also an even integer. It is an integer, but I am getting even integer. Okay, this is integer, this is integer. Whether n is odd or n is even. So I can say it is integer for all values of n. No doubt, whatever it is. So today we have completed this mathematical induction chapter. It's a small chapter and we don't need too many classes also. You have seen how easy the questions were. In the next class, we are going to start binomial theorem. So come prepared with this chapter. See you soon.